Here students, the next concept is particle nature of light. In that particle nature of light, two concepts are present. One is black body radiation, another one is photoelectric effect. Black body radiation concept, best example is iron rod heating. Iron rod heating is nothing but in the welding shops, iron rod heating, color changes we are studying here, simply color changes. That iron rod before heating, that is called as black body, before heating iron rod. The ideal body which emits and absorbs radiations of all frequencies is called as black body. Before heating of iron rod, the color is look like black body. Once on heating, before melting, after final temperature, before melting, different types of colors are we are noticing. That means on heating, the ideal body which emits colors. On cooling, the colors again absorbing. That is the nature of the black body. Simply black body. Once observed here the different color changes of iron rod heating process. Here before heating, the color of the body is look like black. On heating, at initially temperature, on heating, the color black body is changes to dull red. That is emission. This direction is the emission, this direction is the absorption, this direction is the heating, this direction is the cooling. This is emission, this is absorption. So black body on initial temperature converting into dull red. Again temperature is increases, the dull red is converting into red. The dull red is again heating, the dull red is changes to white. Again heating, final before melting, the final color is blue color is appears. Notice this point students, this is the important point to connect it with the Bohr model. All the colors are appears at the same temperature or different temperatures here, different temperatures. All the colors are merging to each other possible? No. One color is appears at one temperature, another color is appears at another temperature. All the colors merging each other is not possible. But in the wave nature of light, in the rainbow, in the Vibgyor, we noticed that all the colors are merging to each other, continuously existing at same temperature we noticed. But here, all the colors are not merging to each other. All the colors are not continuously existing. All the colors are not existing at same temperature. That is the key point. So this point indicates that particle nature of the light. Why it is called as a particle nature of the light? Particle nature of the light here, observed here. After heating the temperature, this is the wave of the red color, dull red color. This is the wave of the red color. This is the wave of the white color. These waves existing continuously or discontinuously? Discontinuously existing. One wave not merging to each other. Another with another wave. So it is a discontinuous process. So discontinuous indicates that light, inside the light particles are present. That light travels in the form of particle, not continuous. It is a discontinuous process. This is packets of energy. This packets of energy we called as quantum. Quantum is nothing but photon. It is a discontinuous packets of energy that is called as quantum. This point. So here on heating, emission of colors takes place. This is the emission spectrum. Here, so black body radiation tells that light travels in the form of packets of energy. It is a discontinuous process. But a rainbow tells that light travels in the form of continuously. These 2 points important. Remember, I am connecting to the Bohr model. So all colors are not appears at same temperature. It is a discontinuous spectrum. So here in this black body radiation, the graph is important students. Graph. Once look at the graph also here. Before that graph, you know that already Vibgyor. In the Vibgyor, this is violet color, this is the red color. Vibgyor to violet color to red color, wavelength what happens? Increases. Wavelength increases means frequency decreases. You know that relation. And before that, one more point notice here. So violet color to, that means dull red to blue color, temperature we are increasing. Temperature is what happens? Temperature increases. Temperature increases means energy increases. So energy increases means frequency increases. Remember this. So temperature increases, energy increases. Energy increases means frequency increases. So energy and frequency relation is what? Directly proportional. Energy increases, frequency increases. So E is equal to, replaces the proportionality with constant, that is E is equal to h nu. So E is equal to hc by lambda. So nu is nothing but c by lambda. What is the relation between nu and lambda? Inversely proportional. This is the equation for finding energy of the wave. Energy of the wave. E is equal to h nu. That is nothing but photon. That is nothing but quantum. Now come back to here. So in the VIBGYOR, violet color is present as well as red color is present. Left to right, red color wavelength increases, frequency decreases. So here, this is the blue color. Temperature is increases. Temperature increases, energy increases, frequency increases. Frequency more means wavelength is here less. Blue color wavelength is less. Red color wavelength is more. Here, blue color, red color I am noticing. Violet color and red color. So wavelength is increases, frequency is decreases. I represented the wave. I am representing like a wave here. This is the violet color wavelength, the distance between the two crusts. This is the red color wavelength, that is the distance between the two crusts or troughs. That is the red color. So by using this, I am giving the graph of this area. Look at here the graph. Look at the graph, students. The graph is existing between intensity versus wavelength. Intensity versus wavelength. Here the three colors I am noticed here. Three colors of the change. So you know that already red color wavelength is more. Red color wavelength. This is the wavelength of the red color. This is the highest peak. So red color wavelength is 700 nanometers. 700 nanometers. This is the blue color. Blue color wavelength is less. Blue color wavelength is less. This is the blue color graph. Between them some other color is present like yellow something. So here wavelength of the red color. Red color appears at high temperature or low temperature? Red color appears at low temperature. Blue color appears at which temperature? High temperature. This is the blue color. Blue color appears at high temperature. So temperature increases, this is the intensity, this is the intensity, this is the intensity. Temperature increases, intensity shift towards shorter wavelength. This is very important point as a statement in both NEET as well as mains point of view. Temperature increases, maximum intensity shift towards the shorter wavelength. Shorter wavelength. Blue color appears at higher temperature, that is existing at shorter wavelength, that is the intensity of the color. So temperature increases, intensity of the color shift towards shorter wavelength. So here based on this concept tells that light travels in the form of packets. It is not a continuous spectrum. So this is the black body radiation. Next concept is photoelectric effect.